Question C of 26 of the 2013 revised higher paper. And it says, why does an alternating voltage be used in a cyclotron? So let's go back and have a look at it. I did explain this briefly in the very first question, part A1, but we'll have a look at it again. Why is an alternating voltage used in the cyclotron? So what's going on here, just to remind you all, is that the particles are entering here at R and they accelerate across this potential difference of 55 kilovolts. When they do that, this side needs to be negative and this side needs to be positive. And so they accelerate across. Remember, they're protons, so they're attracted to the negative plate. And then they go into the magnetic field and they turn around and they exit here. So these are protons, and therefore to accelerate across this gap and to increase in speed even further, this needs to be negative and this needs to be positive. And so they travel around and they do the same thing. And here, of course, whenever they accelerate across the gap, this side needs to be negative and this side needs to be positive. And they go around again. This side needs to be positive and this side needs to be negative for them to accelerate across the gap, away from the positive side toward the negative side. And the same down here, positive and negative. And so essentially, what's happening, it's not, as I've drawn it here, that the bottom half is always positive on one side and negative on the other. The top half is always positive on one side and negative on the other, but on the different side. But that the voltage is constantly alternating. As the electron, or as the proton, travels around here, the polarity switches, and so because the proton has to travel across the gap in the opposite direction to what it was doing before, the polarity must switch so that the proton continues to accelerate and gain speed. So there were 2 points described in the solutions. It said, first of all, the AC voltage needs to change because the force needs to change. The force needs to constantly be accelerating the protons. And the reason for that is because the direction of the protons keeps changing. So hopefully that makes a little bit of sense. But remember, it's not the top half is one polarity and the bottom half is the other. It's just constantly alternating. And I think what's fascinating about this is you can tune this so that the frequency that it needs to alternate at is dependent upon the time it takes to travel around here. But because this particle is traveling faster, even though it's traveling a larger distance, the time between one alternation and the next is the same. So it changes direction and then it travels around here, but because it's traveling faster, it can do that distance in the same time as it did this shorter distance because it was traveling slower, and again this shorter distance because it was traveling even slower. So it's a fascinating piece of engineering. Obviously works well, but that's the answer to part C.